Okay, hello everyone. Welcome back to chapter 3. I guess welcome to chapter 3. Let me share this iPad here shortly. Um, and we will get started. So yeah, we are working now on chapter 3. So we just finished chapter 2, looking at supply and demand, and now we are thinking a little bit more about how consumers or why consumers do the things that they do. And so we'll just do kind of a brief overview and then we'll jump right into everything. Again, I'm going to just try to record these all at once and then cut them up. So if you want to watch these start to finish, go for it. This should be a much shorter chapter than the last one. So I think we'll be okay. So as a section overview, in this chapter, we're just going to cover five main things, right? So we're going to talk a lot about preferences, and preferences are exactly what they sound like. There's nothing special in economics that changes the way that people should speak about preferences or interpret preferences. And so preferences are just to predict other, like we're going to use five properties to predict which combinations of goods or what we're going to call bundles of goods an individual prefers to other combinations. So if you want to think about a bundle of good as like imagine you were quite literally creating like a basket that you were going to take to somebody and you want to put in all sorts of different goods, that is going to be the bundle that you buy. We're going to simplify this down into only looking at two goods. So suppose we have donuts and beer. How much donuts and how much beer are we going to buy given some certain amount of money that we give? And that's going to be our preference. And so we're going to be able to buy, maybe we spend it all on donuts, maybe we spend it all on beers, maybe we do half and half, maybe we, all of those are different bundles of goods and we're going to have different preferences towards them. And so we're going to be able to choose what ones we want. Then we're going to do this thing called utility. Utility is this funny word that economists use to just essentially say that, like, this is how much pleasure we get from consuming a certain amount of goods. And it just assigns a numerical value to each possible bundle, reflecting our rankings. And so it's a funny way of saying, like, we'll say utils as units, but we mostly just treat it as, um, we mostly just treat it as just kind of a way to say ranking or pleasure. And then we've got our budget constraint, which is exactly what it sounds like, right? So we've got prices, income, government restrictions. We can't buy everything in the world. We only have so much money. One of the things that is kind of unique in our approach is that we're going to be treating budget constraints as we're only going to be buying things like only going to be splitting it between the two goods. So we're not going to be able to set it aside to save, or we're not going to be able to spend it on something else. We're going to assume that we've got X amount of dollars to spend on beers and donuts, but we can't spend it on anything else, even though we'd want to. And that's just going to simplify our analysis down a bunch. And then we've got constrained choices, right? So consumers want to maximize their pleasure, their utility, from consuming various possible bundles of good given their incomes, which limits the amount of goods that they can purchase. And this is ultimately going to come down to behavioral economics, which is my wheelhouse. So if you want to talk about behavioral economics, we can do that. But essentially, just like this would be the rational way to approach everything, but people don't always act rationally. And so there's this entire new subfield of economics, well, not necessarily new, but there's this entire subfield of economics that is devoted into seeing like why people break away from rationality like they do. So I think let's just get started. So we're going to do this first video about preferences. So we're just going to look at that first part. And so this is our problem. So this is what we're normally going to look at when we think about an economics problem. And when we think about this, this is going to be called the consumer's problem. And it is a utility maximizing problem. So this yellow part down here, the way that you would read this is that we want to maximize utility. So max u by choosing x and y. So anything that exists under, right? So I guess let's put this in green. Anything that's under is going to be what we're going to call our choice variables, right? And then our big U is going to be our objective variable. Right, so we're going to be able to choose the amount of x and the amount of y to try to maximize our utility at the most. And then again, this is just an implicit function here of the utility, right? So that just means it's going to be some combination of x and y, whatever. So what we now have is we can introduce a lot of interesting ideas now that we've kind of understood the like format that these problems will show up in. And the first is at an opportunity cost, and that's going to be kind of where the value of our goods come in for. So if we're thinking about that we have six beers and six donuts, how much would you be willing to give up for one donut in order to get another beer? Like how many beers would you have to give up in order to gain another donut? And so what are you giving up to take this bundle? If we spend all of our money on donuts, what are we like what is the opportunity cost that we're avoiding? Um, in if we would have bought beers. Similar things, there's a very similar concept called trade-offs, right? It's the quantity of good given up to get another good. And so this is just purely the like one to one, like, oh, it costs me two beers for every one donut. That's not necessarily the opportunity cost because we're just talking about quantities, but they're super, super linked. And then utility is just the well-being or level of satisfaction, and our decisions is going to be how we choose the X and Y given our optimal choice. And then again, we're going to say this phrase down here at the bottom, this subject to some budget constraint, and this is going to show up in something that looks like this, where we're going to have our income Y, our price X times our quantity X, and our price of Y times our quantity Y. So essentially, if donuts cost $1, beers cost 4, we're going to have $1 donuts, $4 beers, and if we have 50 bucks, what combinations of those need to happen? Because again, we're going to spend all of our money, so we're going to be able to do some things in between. So there's a couple assumptions that we have here now too, right? So we're going to want this thing called completeness, and it's going to be rankability. So given two bundles, we are going to be able to choose between the two, right? And so we might be indifferent between two bundles, and that's perfectly okay. We're going to do these things called indifference curves. But given a bundle A and bundle B, we should be able to either say that we prefer bundle A or we prefer bundle B, or we're indifferent between the two. But if we prefer bundle A to bundle B, then we shouldn't that shouldn't flip depending on how the bundles are going to look, right? So essentially, A preferred to B always. Transitivity is that if we prefer A to B and we prefer B to C, then we should prefer A to C, right? So just if we like one more than the other and we like this other more than this other thing, then we should like the first more so than the other thing, right? And then the other thing is that we want this concept of more, right? We're going to be dealing with different quantities. More of a good commodity is preferred, but more of a bad commodity is less preferred. So we can think of a good commodity as like all goods that we would think of, but a bad might be something like pollution, right? As we purchase goods, we might be polluting, we might want to deal with like this net bad, right? And then this results to this ultimate thing here called this diminishing marginal utility. And this diminishing marginal utility is kind of the key that makes behavioral economics work. Consumer problems work. The more of a good that you want, the less benefit you get from each additional good, right? So if I have no donuts and I get my first one, my utility is going to be huge, right? I'm going to get a huge bump in serotonin. I'm going to get a huge utility bump. I'm going to get a huge preference bump. Um, but if I already have 12 donuts, getting a 13th donut is not nearly going to be as beneficial to me as the first donut or as the second donut, right? And so the difference from one to two is going to be bigger than the difference from two to three, so on as the difference between 12 and 13, the difference between 100 and 101. And so the reason that this shows up is that we're going to have these graphs that are going to look like this, right? So if we wanted to say like utils or additional utils and number of donuts, we want this to be concave. We want this to be downward. We want these marginal returns to be less, right? And so this slope here is a lot bigger than this slope here. That's all that that says. Okay, so now let's talk about indifference curves, right? So when we're thinking of indifference curves, and you may have seen something, they kind of look like this, um, where you've got these sloping curves, and we've got good one and good two, right? And these curves here are simply just what are the combinations of good x1 and x2 that I'm going to be indifferent between, right? And so at all of these levels, if I'm on this red curve here, I'm going to be indifferent between the combinations of x and y. But if instead I want to shift to this green curve, like maybe I get more money, um, I'm always going to prefer the green curve to the red curve, right? And that's what we mean by the bundles of A and the bundles of B that we're going to need to be able to like consistently say that things are different, different for. And so these are five properties of the indifference curve. One, bundles on the indifference curve farther from the origin, so green compared to red, right? So green compared to red are preferred to those on the indifference curves closest to the origin, right? More is better, right? The other thing is that we want every single combination of goods to lie on some sort of indifference curve, right? And so typically, like if we could think about it in a lot of different ways, this would be a completely smooth plane, right? And so here, let me, instead of just saying this, this would be a completely smooth plane, right? So there would be thousands of curves that line up across everything. And so every combination of x and y would be on a curve. But not only does this look gross to look at, right? Because ultimately it's just going to end up being a completely red square. We usually just draw two or three to kind of illustrate our point. And I think that that's an okay way to do this. But that's going to be called completeness. Just we want to make sure that we are completely satisfying everything. The other thing is that indifference curve cannot cross. So again, if we're going to prefer green to red, if they crossed like this, at here, we would prefer red to black. But down here, we would prefer black to red, which just doesn't work. We want to make sure that we can consistently keep this across. And again, these curves are always going to slope downwards for our diminishing marginal returns. And what this means is that the indifference curves can't be thick, is that they're only going to take up one line. It's kind of very similar to this completeness idea of that it's only going to be one line. Like we're not going to have just this kind of thick indifference curve. Okay? And that's going to be it for kind of the first introduction into indifference curves and utility. And so I think if you guys can understand this, I would read, like, if you guys are still curious or something, read the textbook. All sorts of good things are in there. They're going to go through a little bit more, like, what it means by indifference curves can't be thick, if that's what you're looking for. But I ultimately think that, like, we'll be pretty okay if you guys are good there. Cool. All right. Now,